Good morning, Mr. Stats Sensei, Mr. Spensei, and this is test review 3A.10, and this for classical and conditional probability. This is part B. It'll be problems 26 through 50. It says, what is the probability a family own a dog? Well, let's circle what dog is. Well, dog is right there, and so the probability of a dog equals 0.26 plus the 0.13, so that equals 0.39. What's the probability a family owns neither a cat nor a dog? Well, that means I need to find this area out here that's not even drawn. I need this box. And I need to find 1 minus the probability of a dog or a cat, dog union cat. So 1 minus that probability. So what is the probability of a dog union cat? So the probability of a dog union cat equals the probability of a dog plus the probability of a cat minus the probability of cat and dog. But here they shortened it up. We can just add up these, the probability of a dog union cat equals 0.26 plus 0.13 plus 0.21. So when we add that up, that adds up to 0.6. So the probability of a dog union cat equals 0.60. So here I just need to go, okay, what's 1 minus that parenthesis 0.26? Oops, problem with writing in pen, parenthesis 0.26 plus 0.13 plus 0.21 equals 1 minus 0.6, which equals 0.40. Okay, next one. Given a family owns a cat. Well, so remember when we say given, it's intersection over given, which in this case, what were we given? We're given that it was a cat, so we're out of the cat. But we need to figure out the probability of a cat. Well, the probability of a cat is that right there, that whole circle. So that whole circle, the probability of a cat happens to be 0.13 plus 0.21, which it happens to be 0.34. And it says, what's the probability they also own a dog? So we want, up here, we want D intersect cat, dog and cat. So we're looking for that intersection. Well, that intersection is very simple. That's where they're both were circles. So that's 0.13. So we end up with 0.13 equals 0.34, and that equals 0.3823. A survey of families revealed 74% of all families eat turkey at holiday meals, and 32% of the families eat ham. So let's start at 74% eat turkey. And 32% eat the families eat ham. So then we have our ham families. And 21% eat both. Well, this is the both. And we can say, hey, you know what? This is 0.21. So that's where the both is. Well, at this point, now I can go back and figure out how many eat turkey. because turkey is going to be 0.741, or this is turkey alone. When I subtract those out, it equals 0.53. So 0.53 eat just turkey. And over here, 32%. So this is 0.32 minus 0.21 equals 0.11. So in this case, 11% eat just ham. So I need to find out this neither part because it wants to know how many eat neither. So there's a couple ways we can do this. And I'm going to do it both ways. I could go, so we have the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. So I could do the probability of turkey union ham equals the probability of turkey plus the probability of ham minus the probability of turkey and ham. Well, we know the probability of turkey is 0.74. We know the probability of ham is 0.32, and we know the probability of both is 0.21. So this is our both. This is turkey, and this is ham. And if I add all that up, sitting here without a calculator, 0.74 plus 0.32 minus 0.21 is 0.85. So the probability of turkey union ham equals 0.85. So if I take 1 minus 0.85, I get 0.15, and that would go right there. That's probably the long way, because the probability of neither is 1 minus that. Now, the short way would have been to say 1 minus parenthesis 0.53 plus 0.21 plus 0.11. And if I'd done that, I would have had 1 minus 0.85 equals 0.15, which is exactly what we got. So this right here is the probability of neither, and I highly recommend you label that. Okay, the probability of A, the intersection A union B is 0.40. Find the probability of B. So I need to write my formula, which is probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. A happens to be 0.55. B, we don't, oh, excuse me. A union B is 0.40. So this is 0.40. This is 0.55. B, we don't know, so I'm just going to write B. And our intersection is 0.42. So I can add up these two, and now I have 0.40 equals point. When these combine, I end up with 0.13. Plus B. I subtract 0.13 from both sides. So I'm going to write this over here. So I have 0.40, equals 0.13 plus B. Subtract 0.13 from both sides. Sorry about running out of room. And I end up with 0.27 equals B. And that's my answer. Now, real quickly. A union B. A union B is right here. And A right here. B we don't know. And our intersection is right there. All right, hope that helped. Keep continuing moving on. Suppose that 40% of the cars in your area are manufactured in the United States, 30% in Japan, 10% um, are Germany, and 20% other companies. I'm going to say, hey, so we're going to say 40% equals US, and I'm going to turn that into a decimal. 30% equals J for Japan, and that's 0.30. And then 10% in Germany, so that's 0.10. And then 20% equals other, which is 0.20. And if I add those up, they add up to one whole. All right. Now, as a fraction, I can be written as 4 over 10, 3 over 10, 1 over 10, and then 2 over 10. The car, so what's the probability that the car is selected as made in Japan or Germany? Well, what's Japan? 3 out of 10, and Germany's 1 out of 10. So 3 out of 10 plus 1 out of 10 is 4 out of 10, which is 0.40. Two cars from Japan are selected. Well, that means I have Japan and Japan. Probability of Japan is 3/10. I needed two blanks because we're selecting two cars. So this becomes 9 over 100, which is 0.09. Once again, we have to see the fractions. None of three cars came from Germany. So as soon as I see none, I'm going to have to do 1 minus. Oops. So 1 minus. But what am I 1 minusing? Well, three cars, and they're not German, not German, and not German. Well, this one can't be from German, and this one, as soon as I say and, we're multiplying. So what's the probability they're not from Germany? Well, not from Germany would be 1 minus 1/10. And someone's probably going, could I have just done this? And yes, you could have. You could have gone 1 minus 0.9 times 0.9 times 0.9. And when you do that, that's the same as going 1 parenthesis, or clear, 1 minus parenthesis 9 raised to 1 minus parenthesis 9 divided by 1, 0, raised to the 1, 2, 3. And we get point, um, I'm sorry, I did this problem incorrectly. Probability of not from Germany is just 9/10. You know what? I'm going to do this in a different color. Probability of not from Germany. 1, 2, 3. Not German, not German, not German. Probability of not German, 9/10. 1 minus 1/10 gives me 9 out of 10. So in the calculator, it's parenthesis 9 divided by 1, 0, raised to the third power, which is 0.729. Apologize for that error. Glad I caught it before I went all the way through the video. At least one of the cars is US made. Okay. So at least means we have to do one minus the opposite of what they asked for. One minus the opposite of what they asked for. So one minus opposite of US means not US. So not you, not you. And this is what I thought I was doing on a problem before. Well, what's the probability that they're made in the US? 40%. So not US is 60%. So this one can't be made in the US, 60% chance, 40% chance is made in the US, the complement is 60%. So 1 minus 0.60 raised to the third power is 0.784. The first Japanese car is the fourth one selected. So this is a Japanese car, but this is not Japanese, not Japanese, not Japanese. Well, the probability of a Japanese car is 0.30, and 1 minus that is 0.70. So essentially we have 0.70 to the third power times 0.30. I can write that a little bit neater. So let's do that. Point, parenthesis 0.7, raised to the third, parenthesis 0.3. And we end up with 0.1029. All right, 36. The XYZ Office Supplies Company sells calculators in bulk at wholesale prices, and here they are. Let's check this out. This plus this is 3, plus 3 is 6, plus 4 is 10. That equals 1. It's a valid probability distribution. What's the expected number of calculators? So we're going to go to stat edit and up arrow and clear, up to the top and press clear. And I'm going to input that data. So I have 2,000, 5,000, 10,000, 20,000. And then I have 0.1, 0.2, 0.3, 0.4. Stat calc, one variable statistics, blue 1. Make sure your freak's on, blue 2. And then zoom, excuse me, then enter. And I end up getting 12,200 because it's asked for the expected value, which is my X bar or my average or my mean. And we came up with 12,200 calculators. Right there is my X bar. Okay, here it asks me to complete the table and find the standard deviation. Well, I remember I have to add this up to 1. So this is going to be 1 minus parenthesis 0.25 plus 0.15 plus 0.1 plus 0.2. When I do that, I end up with 0.30. And I'll show you that in just a second. So here we go. 1 minus parenthesis 0.25 plus 0.3 plus 0.15 plus 0.1 plus 0.2. Try it again. 1 minus parenthesis 0.25. We're going to leave out the 0.3 this time, plus the 0.15, plus the 0.1, plus 0.2. That leaves us 0.3, which we filled in there. Now we need to find the expected value, which means they're asking for the X bar, which is the average or the mean. So we're going to go back and enter that data. Stat edit, up arrow in clear, and then up arrow in clear. And we have 0, 1, 2, 3, 4. And 0.25, 0.3, 0.15, 0.1, and 0.2. So stat calc, one variable statistics, blue 1, blue 2. And we get an X bar or expected value of 1.7. And our standard deviation is 1.425, 1.4525. Please remember, this is my standard deviation symbol. So 1.4525, and we'll just truncate it and cut it off. Okay, continuing on. Okay, for flights from a particular airport in January, there's a 30% chance of a flight being delayed because of icy weather. There it is. If a flight is delayed because of icy weather, if tells me it's conditional, there's a 10% chance it'll also be delayed because of mechanical. So this one is icy weather and mechanical. So that's where that 10% is. This is 1 minus 10% or, okay. If a flight is not delayed because of icy weather, there's a 5% chance it will be delayed because of a mechanical problem. So not delayed, icy weather. So this is this. Okay. So if one flight is selected at random from the airport in January, what's the probability the flight selected will have at least one of the two types of delays? So this is um, taking out of the entire thing. It says if one flight is selected at random, what's the probability the flight will have at least one of the two types of delays? Well, one of the two types of delays would be, it could be an ice delay or a mechanical delay, or it could be both. So really what we're doing is we're saying that what's the probability of A union B? So ice union mechanical. Well, the probability ice union mechanical equals the probability of ice plus the probability of mechanical minus the probability of ice and mechanical. So if I did that, I'm looking for this. What's the probability of ice? Probability of ice is 0.30. What's the probability of mechanical? Well, that's 0.065. What's the probability of ice and mechanical? 0.03. So let's add those up and see what happens. So 0.3 plus 0.065 minus 0.03 is 0.335. So the probability of ice union mechanical equals 0.335. That's the probability of having this or that. Now, the reason we had to subtract, that's a probability of ice. That's the probability of mechanical. Notice this got counted twice. So since it got counted twice, I have to subtract it out once. But this is my answer. Now, there's other ways to do that, but that's how I'm going to show it. What's the probability a randomly selected flight has exactly one delay? That means it would be ice delay. What's the probability of an ice delay with no mechanical? Well, what's the probability of an ice delay with no mechanical? Ice delay, no mechanical. That's this. What's the probability of a mechanical delay, no ice? That's this. So what I have in blue make up those two. So in that case, it'd be the probability of, that's going to be 0.27 plus 0.035, and that equals 0.305. Okay, the next thing, given a flight has a mechanical delay, anytime I see given, I know I need to write intersection over given. Well, what was I given? I was given that it was a mechanical, so I need the probability of a mechanical. What is the probability of a mechanical? Probability of a mechanical is 0.065. What's the probability? Also had an ice delay, so we want the probability of ice and mechanical. Probability of ice and mechanical is where they cross. That's 0.03. And when we divide that out, we get 0.4615. Okay, a laboratory test for detection of a certain disease gives a positive result in 5% of the time for people who do not have the disease. So we have disease and we have test results. So our variables are disease and test results. So those are our variables. I need to find the one number that's associated with only one variable. So 5% who do not have the disease. Okay, the test gives a negative result in 3% of the people who have the disease. Well, wait a second. This is positive result who do not have the disease. So this has two variables because it's positive result and do not have the disease. Gives a negative result 3% of the time for people who have the disease. So this is also two variables. Large scale studies have shown that the disease occurs in about 2%. Okay, that only has to deal with disease. So disease is that's my one variable. So this is disease and it's 0.02 because that's 2 divided by 100. And this is going to be 1 minus 0.02, which is 0.98. So this is disease and this is no disease. At that point, I can bring this up and write this small. This is 0.02. This is 0.02. This is 0.98. And this is 0.98. And 2% population have the disease. And that's where that came from. Okay. I'm going to use this as the same color just because it came from the same place because it's just the one minus. All right. So then we have positive and negative results. So you can put plus and minus, positive and negative. A laboratory test for positive results 5% of the time for people who do not have the disease. Positive for no disease, that's 0.05. We write it small because it's based on two variables. So that's 5% and no disease. And this is going to be 1 minus 0.05. So let's go ahead and multiply those out. So 0.98 parentheses 0.05 is 0.049. Point 0.931. Add these two up and we get to this. Here, large-scale studies have shown the test gives a negative result 3% of the time for those who have the disease. So negative result 3% of the time for those who have the disease. So this tells me this is 0.03. And this is going to be 1 minus 0.03 because it said negative. So 0.02 parentheses 1 minus 0.03 is 0.0194. And when I multiply this out, and by the way, you're going to get a weird number, and I want to talk to you about it. 0.02 times 0.03. That means I just have three zeros. Whatever that negative is tells me one less than that is the number of zeros I have in front. So this means I have 0.1, 2, 3, 6. And if I add those two numbers up, plus 0.0194, we get 0.02. So now I need to add, so this plus this equals this. This plus this equals this. Now I need to add a cross. 0.0684. I need to add a cross. And I get 0.9316 when I do that. And if I check, let's add those two numbers. We get one whole. All right. Appreciate you watching. Hope this helped. Good luck studying for your test. See you on the next one.